Welcome to the Titration Lab. We've got Jim here. He's going to clean out some of these burettes and we're going to do a titration. So let's clean out the burettes first, Jim.
So I'm going to add some water first. Just to rinse the inside of the burette with water.
Maybe about 10 mils or so, right?
Yeah, give or take.
Yeah, give or take. Doesn't matter. Not exactly that. Notice we've got these little funnels in the top as well. That's really handy. Alright, so he's going to empty that.
So I'm just using a waste beaker for this purpose.
Try. Now, usually I think it's good to do this twice. We're just showing you how to do it once here, but I would recommend doing it twice, this part with the water. So he's just emptying it now into a waste beaker. Now, sometimes what we notice is that the water can stop, especially when it gets kind of close to the bottom, and that's because there might be an air bubble, and you can just knock it, and that will usually knock the air bubble out, and then that will make the water continue. Now keep in mind it's going to go more slowly as it gets closer to the bottom because of the pressure. The amount of pressure on top is going to decrease. So he's just again emptying the water out there. Now you'll notice that there's two positions on the burette. For the stopcock, you've got open and you've got closed. This one's open and the one on the left is closed, as you can see there. So it's important to make sure that you need it open when you need it open and closed when you need it closed, especially when you're filling it. You always want it in the off position. So let's go ahead and add some acetic acid. Now what we're going to do is we've labeled the first burette. Would you point to the first burette, please, Jim? That one's A, that's acid, A for acid. And the other one is B for base, and we've labeled those. Now if you like, you can also label the stand if you want here. You can label it right here, A and B, but in any case you need to make sure that you keep the acid and base. I like A, B because it's in alphabetical order. Now he's going to go ahead and he's going to pour an acid sample into that beaker. And that's been labeled with a big A as well. That's good.
Now keep in mind, when you do this experiment, that you're not going to know the molarity of the acid. We're using this as illustration.
That's right. And here we've got the base. Now I know it says 0.2 molar on that acid, but you're not going to know what the acetic acid is.
And the base will be labeled?
But it's going to be labeled a lot more accurately than 0.5 molar. It'll be labeled probably to at least 2 decimal places, so that you'll be able to tell exactly what molarity you're using. But it's going to be somewhere in the realm of 0.5 molar, but it won't be exactly that. We've also got a container here of phenolphthalein. Would you hold that up, please, Jim? And that's going to be the indicator that we're going to be using. Now, as a general rule, I like to wash out my burettes with water first, and then whatever I'm putting in the burette, I'd like to wash it out with. So we're going to go ahead and put, say, about 10 mils of the acetic acid in the acid burette. And you can see he's kind of doing this so it sloshes around, so it washes in. But just about 10 mils is about all you really need there. And I'd recommend, again, doing that twice as well. But he's just going to show you once here, and he's going to let out the acid. All right, so we're just going to let that run out. Then we're going to do the same thing with the base. And then we're going to fill the burettes with whatever thing they need to have in them, whether it be acetic acid or the sodium hydroxide.
Please be mindful that these are acids and bases, and especially the sodium hydroxide can be quite dangerous.
That's right. If you get it in your eye, it's likely to cause blindness immediately. So that's why it's important for you to be wearing gloves and to be wearing your safety goggles at all times. So you notice we're just using the same beaker here. If you wanted to, you could use a couple of beakers as waste and do it simultaneously. That might save you a little bit of time as well. But we're just using the one beaker here as our waste, and then we're going to end up putting that into a waste container or disposing of it in the method set forth by your instructor. Alright, so we've done that, and like I said, I think you should do it twice. But we're just going to show you how to do this once. Now Jim's going to go ahead and fill these burettes. Now when we fill them, we don't have to fill them to the 0 mark, but somewhere between 0 and 3 is probably optimum. In this case, I don't know. Do we have enough acetic acid? Yeah, we think we do.
No, I'm at the 22 mark right now.
Oh, okay. Well, let's go ahead and fill it to 0 or around about. I think as a general rule, it's good to fill the burettes to close to the top for each titration. That way you don't run out of material. Otherwise, you can be taking real chances that you'll run out of material in the burette and have to refill the burette. That's going to really kill your accuracy.
I'm approximately 1 milliliter at this
that's
time.
good, and I'm going to actually zoom in on that in a minute and show exactly what that looks like. But let's go ahead and fill the base. And we don't have to start at exactly 0 in any case. We just have to know exactly where we're starting with. You'll notice in your lab manual when you put the data in, there's a place for initial volume, and that's what you'll be measuring.
Now, when you're filling these burettes, please be mindful of how fast you're pouring the liquid. You do not want to take the chance of overfilling the funnel.
That's right. And the other thing is, once it gets close to the funnel, you see the funnel takes up a lot of volume in the top there, and it can come out very quickly once it hits that funnel. So that's why we're always pretty careful. I try to fill it to below the funnel and not above at any point. Things get pretty bad in a hurry. All right, that looks good. One other good piece of technique here is to try and get the air bubbles out of the bottom part. So Jim, could you just point at the bottom part here, please?
So when I opened the valve, I noticed looked like a lot of liquid, like a break in the liquid. So what happens is there's like a void space in here where my air could be trapped.
Right.
So when you open the valve, the air will come through, and then that space will then be filled with your liquid.
Right. So we've done that for both of these, and you should do that before you begin to take any measurements, because you really need to take account of any air that's been that was in the burette. Make sure it's gone. Let's take a look at a burette measurement here. Let's look at the base here, please. Jim, could you please take that off? Yeah, let's go ahead and take the burette off, and we'll put it in front of the camera so that we can see exactly what we're looking at. All right, so now you can see where the meniscus is. And we'll just move down a little bit further, stop right there. And you can see that the meniscus is between the 3 and 4. Now you've got to remember that with the burette, it measures downwards. So what we're actually measuring here is empty space. So once that goes down, then we can measure the difference between where it was at the beginning, where it was at the end, and that will be the actual volume that was delivered. Now this is going to be measured to 2 decimal places. As you can see, it's between 3 and 4. Just move it down just a tad, please. And you can see that there's 10 graduations there between 3 and 4. And that meniscus is on the 4th line. So I would call that 3.40. So that's how you should do all of your measurements. They'll always be to 2 decimal places. If it's in between 2 lines, then it would be, let's say it was just a little bit lower, I'd call it 3.45. But if it's on the line, then it's going to be 3.40, but always to 2 decimal places. All right, so Jim's going to put the flask underneath the acid here. We're going to add some acid. It says in the lab manual to add between 12 and 18. We're going to add around about 15. It doesn't matter exactly how much we're adding here. And he knows that, where's it going to start?
It's about 4.5.
4.5, okay, so about 4.50. And he knows he has to run that down to about 19.50 around about if we're going to add 15 mils. So he's going to go ahead and do that. And you can see what he's done there is he's put his finger there so he knows exactly how far to run it down. That's not a bad idea, because then you can make sure that you do run it down far enough. Now one other thing I'll point out here is that the tip of the burette should be fairly close inside the top of the Erlenmeyer flask, but maybe only like a centimetre or so, half an inch, something like that, but not too far into the Erlenmeyer flask. So at this point what we've done is we've added some acid into that Erlenmeyer flask. It really doesn't matter how much acid we add at this point, somewhere between 12 and 18, because we are going to make a measurement at the end once we've done all our back titrations. So let's go ahead and add some phenolphthalein. If we don't add the phenolphthalein, we will not get the color change. When we add the phenolphthalein to the acid, there should be no change to the color. It'll just remain clear and colorless.
And I found between 1 and 2 drops is usually sufficient.
Yes, there's no need to add 15.
I prefer to add 1 drop as opposed to 2. I find it easier to find the endpoint easier that way.
All right. So we're going to now go ahead and add the base to this. Now since we're going to, if we do overshoot, we can use the acid here to back titrate, and I think we will end up having to do that, and that's fine. And that will end up being put into the math here as well once we add that extra. Alright, so now we can see the liquid in the flask here, and I'm going to zoom in just a little bit here so you can see what he's doing is just adding the base and swirling at the same time. Are you beginning to see any pink appear?
I am seeing a little bit of pink.
Right, and you'll see the pink appear. Just stop for a second, Jim, and just put it on the stand here. Just add a little bit of the base, and we'll see if we can see that. See if we can see that little bit of pink enter the solution. Yeah, stop right there. So as you can see the pink in there now. But go ahead and swirl it, and you can see as soon as we swirl it, it goes away. But that's okay. What we're looking for is a light, persistent pink color, like a salmon color. So let's go ahead, and I'm actually going to have Jim overshoot on purpose here so that you can see exactly what an overshoot looks like.
So if you're adding too quickly, you very easily can get out of control, and notice what happened.
Right. So you see he's added too much now. That's way too pink for what we want. We want something that's just a suggestion of pink. Very light pink. This is way too pink. So what we're going to do now is we're going to add some acid to this to bring it back to being colorless, and then we'll add a little bit more base, and we'll try that again. Okay, let's can you do it?
Yes.
All right. Now it's very difficult to get the pink color we're looking for just by adding acid. It seems to be easier to go the other way and get the nice pink color by adding the base. Now stop there. As you can see, we've gone back to colorless now because we've added acid, and now we're going to go ahead and add the base. Now you can see what Jim's doing here. He's rinsing the tip of the burette there because that did have a drop of the acid on there, and that was included in the volume. So let's go ahead and go back to this part here. All right. Let's go ahead and add the base. Now he's going to try and add it fairly slowly here. You're going to try drop by drop here, Jim?
Yeah, I will. I'll try add a drop at a time.
Right. So he's just, there we go.
And you can see it's getting very close.
Yes, because the pink color is persisting for a little bit longer each time here.
And I'm just turning the stopcock valve maybe a quarter of the way until I see a drop start to form.
Right.
And then I back it up a little bit.
Okay, why don't you just try putting a drop on the end of the burette there. So that's what he's done here. He's just put a drop on the very end of the burette, and now he's going to rinse that drop in with DI water. You see, we can add as much DI water as we like because it's not acidic or basic.
And it's already pink.
And I'm looking at that and I see, oh, that's beautiful, look at that.
Now I like to swirl this for about 15-20 seconds just to make sure this pink color persists.
Yeah.
And I can see right now that it's still maintaining a pink color.
That's beautiful. And maybe in about another 30 seconds, that pink color will actually disappear. And the reason for that is because there's carbon dioxide in the air, and the carbon dioxide turns into carbonic acid and makes the solution more acidic, which turns the pink color back to colorless. So as you can see, that's a really nice pink color that we've got here. That's what you should be aiming for in your titrations. Now after you've done that, what you'll do is you'll take a measurement on the burette, how much acid has been added, how much base has been added, and you'll use those same guidelines as I pointed out before. And then the actual amount added will be the difference between your initial and final volumes that you've measured. And then you can do the math and figure out the molarity of your acetic acid.